Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be exploiting a blind-based SQL injection using conditional responses to list the content of the database. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the Academy, I'm going to click on Academy, go down, select the learning path, go down, select SQL injection, select blind SQL injection, and click on the exercise titled Blind SQL Injection with Conditional Responses. All right, let's get started. So if you're not familiar with the theory behind blind-based SQL injection, I would recommend watching the SQL injection theory video that is linked in the description. I will go over the theory briefly in this video since we do need that knowledge in order to successfully complete the exercise. But if you want a more in-depth description, I would definitely recommend watching the SQL injection complete guide video. All right, let's look at the exercise. This lab contains a blind SQL injection vulnerability. The application uses a tracking cookie for analytics and performs a SQL query containing the value of the submitted cookie. All right, so we've got a vulnerable parameter, and that's the tracking cookie. The results of the SQL query are not returned and no error messages are displayed. So because of this, we can't use union-based SQL injection, but the application includes a welcome back message in the page if the query returns any rows. All right, so if the query that takes in the cookie returns any rows, then you get a welcome back message. If it doesn't return any rows, then you don't get a welcome back message. The database contains a different table called users with columns called username and password. You need to exploit the blind SQL injection vulnerability to find out the password of the administrator user to solve the lab login as the administrator user. So we have a few end goals over here. One is to enumerate the password of the administrator. And the second is to log in as the administrator user. All right, let's access the lab. Okay, so it looks like it's a similar application to the one we've been dealing with in the past couple of exercises. If you look at the cookie editor extension, you can see over here that there's two cookies. One is the session cookie, which has this value, and then two is a tracking ID cookie, which has this value. Now, because the exercise tells us, we know that this field is vulnerable, but if you didn't know that it was vulnerable, what you would do is literally fuzz every parameter that talks to the backend. And depending on the responses you get from your fuzzing, then you could figure out whether it's vulnerable or not. Okay, so now you could see there's home and my account. We don't see a welcome back message because this is the first time we use this tracking ID. However, now when we try to visit another page, it would be the second time that we use that tracking ID. And so we should be presented with the welcome back message. So let's go to, for example, accessories. And we get the welcome back message because the tracking ID already now exists in the database. Now going back to home and so on, you'll always get that welcome back message. All right, so let's open up Burp to see how we could confirm that this is vulnerable and then how we could exploit it. I usually use the community edition of Burp, but today I'm going to be using the professional version of Burp. And the reason behind that is because it's just so much faster than the community edition. But all the tasks that I'm going to be performing using the professional edition, you should be able to do with the community edition. It just will be a little bit slower. And if you stick around till the end of the video, we'll also script this in Python. And this way, even if your community edition is too slow, you could simply write a script in order to finish this task. Okay, let's make this a little bit smaller. And I'm going to go to user options, display, and put this at 17. Okay, that should be better. All right, so to intercept the request in burp, I'm going to use my Foxy proxy extension and set it to send request to burp. And then I'm going to hit home, and the request gets intercepted in burp. And I'm going to make this a little bit smaller as well, just so that we could see more of the page. So let's put it at 15 and change this to 15 as well. Okay, that looks better. All right, so send this to repeater because we're going to be running a bunch of requests, and then turn intercept to be off. Okay, so looking at repeater, I'm going to put the request and the response side by side by clicking on this button over here and closing this. Okay, so the first thing to do when testing for blind-based SQL injection is to force a true use case and see how the application responds, and then force a false use case and see how the application responds. If the application responds differently, depending on the true use case versus the false use case, then you can successfully exploit that blind-based SQL injection in order to infer content from the database. So the first thing we're going to do is confirm that the parameter is vulnerable to blind-based SQL injection. And to do that, we have to try and imagine how the query looks at the backend. So I would say the query looks something similar to this. Of course, it's going to be different, but it would be something similar. So select the tracking ID from, say, the tracking table. Of course, all of these would have different names. Where tracking ID is equal to the tracking ID over here. Let's copy that and put it in here. Now, if this tracking ID already exists in the database because we've already visited a page with this tracking ID, then this query returns a tracking ID. And so depending on the behavior that we saw, it should return a welcome back message. So let's hit send over here and see if we get a welcome back message. And we do. So let's make some notes. So if this tracking ID exists, then the query would return a value. And then we get a welcome back message. However, if the tracking ID doesn't exist, then query returns nothing. And then we don't get a welcome back message. And let's confirm that by adding another character to the tracking ID. So that would be a tracking ID that doesn't exist in the database. Hit send and see if we get the welcome back message, and we don't. So 0 matches. And so this confirms there is different behavior between whether the tracking ID exists or not. So whether this condition over here is true or not. So now to confirm that this is vulnerable to blind-based SQL injection, we have to enforce a true use case and confirm that it reacts this way. And then we have to enforce a false use case and confirm that it reacts in this way over here. So to do that, let's copy this. So we're imagining that this is our query. Now, if we want to inject a true use case, what we can do is add a single quote. This single quote over here closes this single quote over here. And then I'm going to use the AND operator and say 1 is equal to 1, and then comment out the rest of the query so that I don't get a syntax error for this single quote over here. Okay, so let's look at our query. You have select tracking ID from the tracking table where tracking ID is equal to this. and 1 is equal to 1. Now, tracking ID, this tracking ID, we already tested with it, and so we know it exists in the database. This will evaluate to true, and 1 is equal to 1 will always evaluate to true. And so this entire where clause will evaluate to true, which will result in a tracking ID being outputted, which will result in the welcome back message. And so we should see, since this is a true use case, we should see a welcome back message. So let's confirm that that's happening. We'll copy our injected code and we remove the character that we added. And then Control U to URL encode it and hit send. And here we go. We find a welcome back message over here, which means that one, it interpreted this as SQL code. So we definitely have a SQL injection, but it also tells us that we get a welcome back message whenever the use case is true. Now, if we can prove that we don't get a welcome back message when the use case is false, then we have an exploitable blind-based SQL injection. So let's do that right now. So instead of 1 is equal to 1, we'll say 1 is equal to 0. So over here, you've got select the tracking ID from the tracking table, where tracking ID is equal to this one. Now we know this will evaluate to true because this is a tracking ID that we already visited the page with. And then 1 is equal to 0. 1 will never be equal to 0. And so this will evaluate to false. False and true is false. And so this entire query will return a false. And we said if it's a false, then we shouldn't get a welcome back message. So let's check if that's actually the case. Let's copy that, put it in the request, do Control U to URL encode it, and hit send. And here we go. We do not get a welcome back message. So we've proved that the application responds differently on whether we're asking it a true question versus a false question. Now, how can this be useful? A simple use case that we could start out with is to ask the application if the user's table exists in the database. So the second thing we're going to do is confirm that we have a user's table. Of course, because this is a blind-based SQL injection, we're stuck asking the application true and false questions, and so we're going to ask the application, does the user's table exist? If we get a welcome back message, that means it does exist. If we don't get a welcome back message, that means it doesn't exist. Okay, so to do that, let's copy this. Okay, instead of saying 1 is equal to 1, we're going to add a subquery and say select any random value, so let's say x, from the user's table and limit the entry to only 1 and check if that's equal to x. Again, x over here is an arbitrary value. It can be anything you want. But the idea is what this query does is it says if there is a user's table, output the value x for each entry in the user's table. So if the user's table has 5 users, we should get 5 rows that have x in them. Now this might destroy our query, and that's why I had to limit it to 1 entry. And so what this says is output the value x for each entry in the user's table and limit it to only 1 entry. Now, is this entry that is outputted equal to x? If it is, then it evaluates to true. If it's not, it will evaluate to false. Now, obviously, if the user's table doesn't exist, this will evaluate to false and we shouldn't get a welcome back message. However, if the user's table does exist, it will output x for the first entry in the user's table. Is x equal to x? It is, and so this evaluates to true. We know the tracking ID evaluates to true because this is the tracking ID we've been using, and so true and true evaluates to true, and we should get a welcome back message. So that's how we're asking the question of whether the user's table exists or not. So let's paste that in our request. do Control U to URL encode it, and hit send. And we get one match. So we see that we get the welcome back message, and so that means that the users table exists in the database. Okay, so the next thing to do is confirm that the username administrator exists in the database. So it exists in the users table. And to do that, we use the exact same technique over here. So let's copy that. So instead of select X, we're going to say select the username from the users table, where username is equal to administrator. And then we're going to check if that's equal to administrator. If it is, then this whole query evaluates to true. Okay, so let's explain what this query does. So select the username from the users table where username is equal to administrator. So this will output the text administrator if that username actually exists in the users table, and then it'll check is administrator equal to administrator. If it is, it'll evaluate to true. If it's not, it'll evaluate to false. So if the username administrator does not exist in the database, this will not output the text administrator, and so that will not evaluate to be equal to administrator, and so we end up getting false, and true is equal to false. So let's check if the administrator user is in the database. And this type of SQL injection is a little bit trickier than all the other types of SQL injections just because you're so limited in what you can do and you're only allowed to ask true and false questions. However, once you understand how it's done, it becomes a little bit easier to get through these exercises. So we did Control U to URL encode it and hit send. And we still get a match, which means that the administrator user exists. Okay, so now let's try it with, for example, the user administrator and something else, a user that we know does not exist in the database because we put random values and hit send, and we don't get a welcome back message indicating that this user over here does not exist in the users table. Okay, perfect. The fourth thing that we need to do is enumerate the password of the administrator user. And again, what we could do over here is copy this, put it in here, and say select the password from the users table where the username is equal to administrator and check if this password is equal to, for example, welcome 2021 exclamation mark. However, this wouldn't be a very smart thing to do. This will work. It will tell you you won't get a welcome back message because that's not the password of the user. However, it's not a very smart thing to do because all you're doing is literally brute forcing the password, which you already can do over here. So if you go to my account and put administrator and then put welcome 2021 exclamation mark and hit login, and you get an invalid username or password. You performing this query is exactly similar to you brute forcing it through the UI. And so it's not very smart to do it that way. Instead, what we're going to do is ask the application a series of true and false questions. The first question is going to be, is the first character of the password A? If we don't get a welcome back message, then we'll move on to the second character. We'll say, is the first character of the password B? If we don't get a welcome back message, we'll move on to C, and then we'll move on to D, and so on until we get a welcome back message. Now, once we get a welcome back message, assuming we get it for F, we'll move on to the second character of the password, and then we'll ask the application, is the character A? If the application doesn't respond with a welcome back, we'll ask it again, is it a B? If we don't get a welcome back message, we'll move on to C, and so on. And so that's why we need to script this and we need to use burp intruder, because it ends up being a ton of requests depending on how long the password is. So that's actually the second thing that we need to do, which is determine the length of the password. And to do that, we're again going to ask the application a set of true and false questions. So we're going to say select users from the users table where username is equal to administrator and password, and the length of the password is bigger than 1. And then we're going to say, is that equal to administrator? And this is not users, it's username. Okay, so let's see what this query does over here. So select the username from the users table where username is equal to administrator and the length of the password is bigger than 1. The output of this query is equal to administrator. If it is equal to administrator, then it evaluates to true. If it's not equal to administrator, then it evaluates to false. Okay, so we know for sure that the length of the password is going to be bigger than 1. So what we're going to end up doing is if this evaluates to true, that means that the password is bigger than 1. Then we're going to ask, is it bigger than 2? And if it still evaluates to true, then we're going to ask, is it bigger than 3? And then if that still evaluates to true, we're going to ask bigger than 4. And so on until it no longer evaluates to true. And that's how we're going to figure out the number of characters in the password. So let's copy that and put it in repeater. And hit send. We should get a welcome back message, and we don't, which means that we did something wrong. And I can see the mistake over here. It's because I never removed the other query. So let's remove all of that and then paste it again. And then do Control U to URL encode it. Hit send. And we get a welcome back message telling us that the password is at least bigger than 1. Now let's try a much bigger number, 50, and hit send. And we don't get a welcome back message indicating that the password is bigger than 1 but smaller than 50. Okay, so you could use a binary search method in order to figure out the password length, but what I'm going to do is I'm literally going to brute force it using intruder. So I just sent this to intruder, go to positions, clear all the positions, and the position then that I'm interested in enumerating is this one over here. So let's put it back at 1. And then click add, and we're using sniper. Go to payloads. The payload that I want to use is numbers, and it's going to be sequential because I want it to start with 1, 2, 3, 4, and then complete it until the end. So we're going to start from 1 and then go all the way to 50 because we know for sure that it doesn't reach 50. And then the step count is 1. And what that means is start off with 1 and then add 1 to that, so 2, and then add another 1, so 3, so on. So you end up with 50 requests at the end. And I'm going to click on Start Attack. Okay, so if you're working with the Community Edition, this will probably take much longer to do than the one I'm working with because I'm working with the Professional Edition. All right, so notice over here that the length is 11403 for when you do get a welcome back message. So in this case, we said is the password bigger than 1, and we got this length. And then we said is the password bigger than 2, we still got the same length, and so on until we reach 20. So when we said is the password bigger than 20, we got a different length than all the other numbers, which means that we likely didn't get a welcome back message over here. So let's search the response, and we didn't. And so this confirms that when we said is the password bigger than 20, this evaluated to false. And so the password over here is exactly 20 characters. Okay, so another way to filter on these items is to look at filter, and you can only do this with the Professional Edition. So we'll filter on welcome, hit apply, and it'll only show you the requests where you got the welcome back message. So in this case, up till 19, you got the welcome back message. On 20, you no longer get the welcome back message because it's not bigger than 20 characters. It's exactly 20 characters. Okay, so now that we know the number of characters in the password, what's left is to enumerate the password. And to do that, we're going to start off with the first character. Again, ask it, is it equal to A, is it equal to B, and so on until you loop through all the alphanumeric characters. And then once you're done, you start off with the second character. You'll loop through all the alphanumeric characters until you get a welcome back message and so on until you reach all 20 characters. And again, you're going to need burp intruder for this because that's a whole lot of requests that you're going to be making. So let's close that, discard it, go back to repeater, and work from there. All right, so to enumerate the first character of the password, let's copy paste this, put it over here. And what we're going to do is we're going to use something called the substring method. And it'll divide up the password. So the first character, start with the first character and only one character from the user's table where username is equal to administrator. And check if the first character of the password is A. If we get a welcome back message, that means the first character is A. If we don't get a welcome back message, that means the first character is not A. So let's copy that. Put it in repeater. And then Control U to URL encode it. And hit send. And we don't get a welcome back message indicating that the first character of the password is not A. Now let's try all the other alphanumeric characters. So we're going to send it to intruder to do that. Again, we go to positions, clear all the positions, and then highlight this one by clicking add. In payloads, we're interested in brute forcer. And this checks all the alphanumeric characters. The minimum length and maximum length is equal to 1 because I wanted to try one character at a time. And I'm going to click on start attack. Okay, so we could see over here, we saw that A did not have the welcome back message and it has a length of 11342. So we're looking for a different length. And here we go. So we could see at 5, we get a different length. And if we look at the response of 5, we have a welcome back message. So we've enumerated that the first character is 5. Now we're going to do that for the second character and so on. So instead of doing this 20 times, what I'm going to do is I'm going to use, so let's discard this. I'm going to use a different type of attack, and that's called at cluster bomb. So instead of just having this as one of our payloads, we're going to add this one as well. So we'll add 1 and then add A. And then in the payloads, so starting with 1, I want the first one to be numbers. And it's going to be sequential again from 1 to 20 because that's the number of characters in the password. And each time I want it to step one number. And then for the second payload, which would be this one over here, I want to add brute forcer and test out all the alphanumeric characters. And again, minimum length is 1 and maximum length is 1 because I wanted to try one letter at a time or one character at a time. And then I'm going to hit start attack. And you could see over here, there's 720 requests. If you try doing it with the community edition, which I did, it'll take hours to run. And so I wouldn't recommend doing it using that. And if you don't have a professional edition, what I would do is just script it in Python, which you'll see will only take a couple of minutes. So we could start filtering out on the welcome message. Hit apply. And you'll see over here for the 10th character of the password, it's A. The 5th character of the password is B. The 17th character of the password is B, and so on. So let's order on this one. And it doesn't order correctly because it doesn't see them as numbers, it sees them as strings. Okay, that's fine. So what I'm going to do, and it's done, so what I'm going to do is put this over here. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so we said the first one is 5. Let's confirm that it is. Okay, number 10 is A. So we'll put that over here. Number 11 is 7. Number 12 is 4. Number 13 is 9. So we no longer need spaces because those will always be ordered. So for 9, 14 is C, Y, 0, B, 7, 6. And then we need number 20, which is S. Okay. And then we'll start off with 2. So 2 over here is 2. Number 3 is R, Q, B, J, T, J, P. Okay, so that should be 20 characters. Let's copy that and try to log in as the administrator user using it. Okay, click on my account, click on administrator, and put in the password and hit login. Okay, it says congratulations, you solved the lab. Okay, so we successfully completed the exercise by using Burp Suite Professional. Now let's try and script it. Okay, as usual, we start off by importing the sys library and the requests library. We also import URL lib3, and we add this line over here to disable any warnings we're going to get from certificates. So URL lib3 dot exceptions dot insecure request warning. And then we're going to set our proxy setting. So I usually like to debug my scripts when they don't work, and it's difficult to debug them if you can't see the requests. And so I send all my requests that are done in the script to Burp so that I can see them in case something does not work properly. So to do that, we'll set HTTP. And then HTTPS. Okay, the next thing we're going to do is call the main method. And we'll define it over here. All right, so function main, and then we're going to say if the length of the input when you run the program is not equal to 2, then I want to print the usage instructions. So I'm going to say usage is equal to the name of the program and then a URL. And I also want to print example instructions just so that it's really clear. And again, name of the program. And let's say an example URL would be www.example.com. Okay. All right. So the way I want to run my program is it would be script.py and it takes in one input, and that would be the URL of the application. And so assuming that we ran it correctly, then we'll assign the URL to the input that we used when running the program. And then we're going to print retrieving administrator password. And then we're going to call the function SQLi password URL. And that function will output the password of the administrator. And what it'll do is it'll show you in real time all the different characters that it's trying. And then once it hits a character that the application responded true to, then it'll set that character and move on to the other character. So let's implement this function over here. So def SQLi password. Again, it takes in the URL. We're going to say that the password extracted is just an empty string for now. And then we're going to use 2 for loops, and it'll make sense once we implement them. So we'll first start with for I in the range 1 to 21. That's the number of characters that are in a password. And so this range over here has to be one number bigger because it'll only test it for that number minus 1. And so it'll test it from 1 to 20. And then we're going to say for j in the range 32 to 126. And that might seem odd to you, and I'll explain that right now. All right, so let's go to ASCII table. And let's try to find a nice image of an ASCII table. This one should work. Okay, so you'll notice over here I started with 32, and what that means is I'm starting with the space character, and then I'm moving all the way to 126, which is this sign over here. So I'm testing not only the alphanumeric characters, but also the special characters as well. And the reason I do that is instead of putting all these characters in an array and then looping through that array, what I can do is just use the decimal representation of those characters, and then we'll convert them to ASCII in the SQL payload, because SQL does support that. And once we do that, it would be equivalent to you asking the application, is the output of this equal to A, and so on. So this will make a little bit more sense once we implement it. So we'll start off with the SQL payload. And the one we were working with is this one over here. And we're going to click on View and toggle Word Wrap. Okay, we're going to make slight changes to this. So we're going to say, we're going to put this in an ASCII function. And this variable over here would be the value of I, so 1 through 20. And this variable over here, this value over here will be the value of j. So between, it'll test out all the characters on it. So let's do that over here. So ij, and then we need to encode it. So SQLi payload is equal to URL lib dot parse dot quote and the SQL payload. So we need to import this over here for URL lib. Okay, and then the vulnerable parameter is in the cookies. So we're going to say cookies is equal to, and that would be the tracking ID. So if we go back to our request over here, it would be tracking ID, and the cookie is equal to this over here. Let's copy that, plus the encoded SQL payload. And then we also have another cookie, which is session. So let's put that in here and add the value over here. Because if you don't have the right cookies, you will be kicked out of the application. So let's copy that, put it in here. And then we're going to make a GET request. It's a GET request because it's a GET method that it's using. So you could see that over here. It takes in the URL, takes in the cookies to be equal to cookies. We're going to set verify to be equal to false because I don't want to verify certificates. And then I'm going to set proxies to be equal to proxies so that it sends my request through burp just in case we need to debug it. And then we're going to say if you see welcome message. So if the welcome message is not in our .text, so the response of this request over here, then we want to output the character that we're trying. We'll use carriage return. This ensures it starts at the beginning of the line plus the password extracted. And then we'll flush the output. And once we run the program, you'll understand what this does. Now, if we do get a welcome message, so in the else case, then I want to add that character to my password extracted string. So that's plus equal to, and I want the character version of it because right now it's in ASCII. And then I'm going to say sys.stdout.write. And again, carriage return plus password extracted. And flush it one more time. And then break. And what that does is it ensures once we do get a welcome message, there's no need to try all the different characters. So all these characters over here, because we already found the character for that position in the password. And so there's no need to try all these characters. Instead, we're going to break out of this second loop and go back to the first loop and move on to the second character. And this makes it more efficient than Burp Suite Professional. All right, let's save this. This should work. Hopefully we don't have any errors. Let's run terminal, new terminal. And this might be a little bit too big. Let's see. And it is. Sizing issues. All right, let's close this. And then run it. Python 3, SQLi lab 11.py. And we need the URL of the application, which I believe must have timed out. Let's go to home, and it did. So we're going to need a new instance. Okay, it loaded, so let's copy that, put it in here. Now, because it is a new instance, the tracking ID and the session ID likely changed, and so let's copy them and put them in our script. So that was for session ID, and yeah, it did change. And then tracking ID, let's copy that and put it in here. Save it one more time. Okay, so instead of running it for all the characters of the password, I'm just going to run it for the first one, confirm it's working correctly, and then get it to run on all 20 characters. So hit enter, and we already have an error on line 34. And we misspelled that, so let's save that. Clear this and run it one more time. And we get one more error. And we said this is equal to cookie, so let's save that. So this happens when you're coding on the fly. Hit enter, and we get an error. Okay, so I've paused the video and Googled it, and I think I know where the mistake is. This does not have two brackets in it. So I think this is the issue because everything else in my code looks good. So let's try it one more time. Okay, perfect. So it's running, but I think we're getting a connection timeout, which is why, and we are, which is why this is not working properly. All right, so let's open up a new instance. It took some time to resolve the error. Go here, access the lab, and we're going to need to change the tracking ID and the SQL payload. So view, toggle word wrap. Tracking ID over here. We'll put that in here. And then the session is right over here. Okay, save that. Take the new URL, put it in here. Let's go back to Burp so that we could see our requests in real time. And we'll start off here. Okay, and hit enter. Hopefully this should work. So one thing that I'm noticing is that I'm not seeing the characters being displayed to me on screen. And I realize right now why. It's because I never put them over here. So let's say plus character J and save it. So let's close this. All right, let's do this one last time. Hit enter. And here we go. So you could see over here, it's trying to enumerate the first character and it's telling you all the different characters that it's using. So it started off with the special characters and now it moved on to numeric characters and now it's trying the alphabets, both capital and lowercase. So we'll let it run until it finds its first character, and in this case it was I. So what we're going to do right now, since it is working, I'm going to put it back to 121 and let it do its thing and enumerate the entire password. Now, since this might take about 2 or 3 minutes, I will fast forward the video so you'll see it play in real time and enumerate the entire password. But I'll fast forward the video so that it takes, 10 or 20 seconds instead of 3 minutes. Okay, so it looks like it enumerated all 20 characters. That definitely took more than 3 minutes. It took about 7 minutes, I would say, but it's still much, much faster than the community edition of Burp. So let's copy that and confirm that it is our password. So I'm going to go to my account, hit administrator, paste the password, and click login. And here we go. It says, congratulations, you solved the lab. Okay, so to recap, in this video, we first used Burp Suite Professional in order to exploit a blind-based SQL injection with conditional responses. Then we scripted the attack in Python. In the next video, we'll also exploit a blind-based SQL injection vulnerability, except in this case, it will be conditional errors instead of responses.